Today we're going to talk about applications of right triangles. Very important. We use right triangles in all kinds of places. Physics uses right triangles. We use right triangles to solve different distances. Okay? Even we can use it sometimes to find the height of mountains. But our process here is we're going to draw and label a picture. That's the first thing we have to do, is be able to draw and label a picture. And sometimes we'll give you the picture, which will help, and then we have to determine which piece of the triangle must be solved for. And then we're going to use SOHCAHTOA, and right now only SOHCAHTOA, and sometimes Pythagorean theorem, but for the ones we do today, we will not be using Pythagorean theorem. But when we get later in the book, we will be using Pythagorean theorem along with SOHCAHTOA. Something that we never want to forget, these two things. All right, so airports measure the height of fog using a spotlight shined at the sky, as shown in the picture below. So they want to know, in order for planes to take off safely, they need to know how high this fog layer is. So they'll have a spotlight set up, and they know the distance from the airport to the spotlight. Say it's 2 miles in this case. Shined up straight up at the fog, and then they are able to measure this angle with their instruments. They can measure this angle, and that is enough information for us to determine how high that fog layer is. So we want to know how high is the fog layer. Okay. Well, the fog layer, the height would be right to this point right here, which would be straight up that spotlight. Now, there's of course no real triangle here, but we are imagining that it's forming a triangle, and then we can use trigonometry in order to solve the picture. So we want to find this side. We want to find the height of the fog. We're going to call it h. How high is that fog? Well, of course, if we look, we have a right triangle. Whenever we have a right triangle, we should automatically think of SOHCAHTOA, and we should automatically think of Pythagorean theorem. Now, in this case, we're going to have to use SOHCAHTOA because we have an angle and a side. The only way you can use Pythagorean theorem is if we had two sides, which we don't. So this is the opposite side, and this is the adjacent side. So we're going to opposite and adjacent from our SOHCAHTOA. Opposite and adjacent is tangent. So we write our equation. Tangent of 31 equals the opposite h over the adjacent 2. And then we just multiply 2 tan of 31. Multiply both sides by 2. 2 tan of 31 equals h. Okay. 2 tan of 31 equals h. Now, in the past, I've told you you could leave your answer that way. However, this is a word problem. We need to know an actual number. It doesn't help us to say that the fog is 2 tan of 30h high. It doesn't tell us anything. So make sure my calculator's in the right mode. 2 tangent of 31, 1.20, which seems quite high. So that seems like it'd probably be safe, but 1.201 is h. Now, that would not be acceptable in this case as well, because a word problem requires a word answer. So we would write a simple sentence. The fog is 1.201 miles high. All right. That would be an example. Now let's do another one. Let's talk about, let's do another example. A ladder is leaning against a wall and it's going to be a 10-meter ladder. So it's a pretty big ladder, 10-meter ladder, leaning against the wall at an angle of elevation of 64 degrees. How high up the wall does the ladder reach? How How high up the wall does the ladder reach? Okay. Now, first thing, draw a picture. So I've got to have a wall. I've got to have a building. Then I'm going to have some building here. And I've got a ladder leaning against that building. There's my ladder. Here's the ground. Okay. Here's the ground. Here's my ladder. And it's 10 meters. Here's my ladder. I'm going to label that properly. This, of course, is a right angle where the building and the ground meet. At least we hope it is. It's going to be in bad shape if it's not. And it says an angle of elevation of 64 degrees. An angle of elevation is a ground angle that is made with the ground. This is an angle of elevation. Okay? When we're starting from the ground and going up. Notice there's always a horizontal line here. Horizontal line. So that angle of elevation, that would mean this one is 64 degrees. Okay? That's the angle that's 64 degrees. Now there's a partner to an angle of elevation, and that would be an angle of depression. We're going like this and going down. This angle in here is an angle of depression. Now, so we've drawn our picture, we've labeled it. Now we have to determine which side do we want to find. And it says, how high up the wall does the ladder reach? Well, that would be this height right here. That would be how high up the wall the ladder reaches. So that's the opposite side. And I'm given the hypotenuse is 10. So now I do sine, SOHCAHTOA, sine is opposite over hypotenuse. So in this case, we're going to use that. So the sine of 64 equals the opposite h over the hypotenuse, 10. Multiply both sides by 10. I get 10 sine of 64 is h. But again, can't leave it that way. So 10 sine of 64, 8.987 or 8.988. I would accept either one. So the ladder reaches 8.987 meters, don't forget the units, up the wall. Word problem requires a word answer. Okay. Well, let's do an example now where we have to find an angle instead of finding a side. Okay. So an airplane is 1.5 miles up and 16.2 miles from the airport. Okay. Now, the airplane is 1.5 miles up and 16.2 miles from the airport. At what angle must the plane fly to land safely at the airport? Okay. So let's start. We have to draw a picture, and we can start with something as simple as the airplane's here and the airport is down here. And we're assuming the plane's going to come in something like this in order to land. And so we would have to know where our right triangle is and what our distances are. It says it's 1.5 miles up. So it's 1.5 miles above the ground. So if I'm here, then if the ground is here where the airport is, then here, this is 1.5 miles. It's 1.5 miles up. And it says it's 16.2 miles from the airport. Now be careful. Okay, 16.2 miles from the airport means is if the plane were to continue flying straight here, in 16.2 miles it would be directly over the airport. So that's this distance actually. 16.2 miles is this side here. And it says at what angle must the plane fly to land safely? It's going to be an angle of depression. So an angle of depression starts, as we go back here for a second, an angle of depression starts with a horizontal line and then goes down. So you need a horizontal line here. So imagine if the plane was flying this way, this would be the angle of depression. I say, wait a minute, that angle is not in my triangle. No, it's not. However, it is the same as one of the angles in the triangle. It's actually the same as this angle over here. We'll call it theta. This angle and this angle, this is an angle of depression. This is an angle of elevation. And those angles are the same. The angle of depression from the airplane to the airport is the same as the angle of elevation from the airport to the airplane, which makes perfect sense. So this is actually the angle we want to find. So now I have, this is the opposite side to that angle, and this is the adjacent side to that angle. So again, SOHCAHTOA, tangent of that theta is the opposite 1.5 over the adjacent 16.2. We have to use the inverse tangent to get rid of that tangent. So we take this 1.5 divided by 16.2. So tan inverse of 1.5 divided by 16.2. Oops, I put it in correctly here. And we get 5.290 degrees. Okay, so the plane must take an angle of 5.290 degrees. Now we always have to ask ourselves when we're doing this if our answer is reasonable. And I've seen kids get an answer like 85 degrees. So the plane would take an 85-degree angle. Let's be careful to think about that because that's not called landing the plane if you take an 85-degree angle. That's called crashing the plane. You need a small angle if you're going to land the plane safely.